It's a pretty important update for the robot project. Alright. So this is my updated servo design. I'm making custom servo motors for the robot. Here we've got a DC motor, could be brushed or brushless. We're using brushed motors for some of the finger joints and stuff like that that don't require a lot of strength. At least that's the plan right now. And brushed motors for all the bigger muscles of the body. Okay. So the motor has an output shaft drawn here, and along that we're having little flanges that we're going to glue on into place. So we've got 1, 2, 3 flanges. The output shaft is supported being pulled downward, since the muscle might want to pull upward. The tugging is going to be upward. So it's being held downward by a little steel ball, like a bearing ball, and then like a little nylon bowl facing downward onto the ball, and the bowl is tied down with string to the bone of the robot. So this line represents the bone of the robot that this is all attached to. Okay, so the string will sew it down to the bone, and the bone again is covered in fabric so it can be sewn into. Alright, so that holds everything down, and then the motor itself is also sewed down into the bone. The motor is wrapped in like a football jersey mesh, so it can still breathe, but it's being able to be sewn to, so it can sew down onto the bone as well. We can't use screws or brackets with bolts to bolt things down, because that would compromise the structural integrity of the bone. So we're sewing it onto a fabric sheath that's double stick taped onto the bone and sewn tight around the bone. And then we can sew all the components into that. Here we've got a little nail or a small steel bar that comes across, and it's sewn into the top of the motor, and then it's sewn into the top of this bowl. And that will enable us to then mount the next phase, which is a downgearing system. So as this shaft turns, if it were to turn counterclockwise, that would release this string, but counterclockwise that would pull this string down. And if it pulled this string down, then it would be reeling this one in while undoing this one. So they're equal and opposite. So anyways, the strings, depending on the direction of pull, will wind or unwind these top two. Now, notice that the shaft diameter of this is smaller than the shaft diameter of this. So many small turns make this turn one time. And because this turns slower, then if these are coupled, two more small shaft ones, then these are going to turn slower and transfer a slower speed to these wires that ultimately will lead to the muscles through muscle wire. Actually, I should draw the string all the way up. And by muscle wire, I just mean strings that run through hollow tubing that lead to the muscle. So this is our downgearing system. Now, if you made these even bigger diameter and this even smaller diameter, the way it's drawn here kind of looks like a bigger diameter, but it's actually probably going to be about half this thickness, and we can make this any thickness we need to downgear it even more. We just want to have one. We don't want to have another set of pulleys that downgears it even further. I'd like to do it with just one. So if this turns a really small diameter and then this is a bigger diameter, that will slow down the motor, converting speed to torque. So this is how we do it. And this can all be 3D printed and just mounted with a hole drilled down the center perfectly, mounted onto this nail shaft, which is sewn to the motor. So yeah, these should be very simple to make. And these are just little flanges glued onto the output shaft of the motor. And then the string is glued on, and you just start wrapping it a few times, and you send it up and wrap it around that a few times. And then you're done. So yeah, that's how we're going to downgear these motors. Now, I've already drawn this before, but this is an upgrade where instead of having direct drive from this to the muscle, I'm going to actually downgear. Now, I may not always need to down gear. Like, let's say one motor is controlling just the movement of the eyelashes. We might want the eyelashes to move at very quick speeds to blink quickly, and we wouldn't need a lot of torque or power at all, and so we would just let the rotating of the motor just wind up the string and cause the eyelash to blink at maximum speed. But if we find that the motors are actually moving too fast and they're also too weak, we can trade speed for strength, slowing down the output of the final strings by just having this down gearing system that is completely free to make just tiny little 3D printed parts. You could even make it yourself, but I think it's quicker actually to 3D print them. You could just 3D print them in bulk. They're going to be so tiny. They're going to be like the size of the tip of my thumb for all this. I mean, look at the scale of this. This motor, well, I have some motors that are going to be this actual size compared to my thumb, but a lot of them, like the ones for the fingers, are going to be substantially smaller than that. So this is a really good design for down gearing. It's all plastic construction, except for this little metal shaft, which I could just use a trim nail for. So that's simple. So that's how I'm going to down gear my little motor pulleys to make my own custom servos. Hope you guys enjoyed that.